Hello, my dear students. Let us see the various methods of studying correlation. There are mainly three methods for us to study. They are scatter diagram method, Carl Pearson's product moment method, and Spearman's rank correlation method. As far as scatter diagram method is concerned, we draw a scatter diagram for the two variables, say x1 and y1, and then plot all the points of the two variables given on a graph. There are two axes, as you know, x-axis and y-axis. X-axis, which is the horizontal axis, is plotted with x variables, and y-axis, which is the vertical axis, we plot y variable. And once we do that, depending on the nature of the curve or the diagram, we understand which type of correlation exists there. If the points are plotted on a straight line going upward from left to right, we have perfect positive correlation between the variables x and y. Here what happens is, when one variable changes, the other variable also changes in the same direction and in same proportion or in a particular ratio. Then we get a straight line going upward from left to right. This is perfect positive correlation. Here you may have different examples, as is given on page number 62, illustration 1. You can see three columns there: person, taxable income, and income tax. So taxable income and income tax are the two variables, x and y respectively, and we plot these variables in a diagram, and we get a straight line going upward from left to right. This is a case of perfect positive correlation. So please go through this particular example and understand the meaning of a perfect positive correlation, which we get in a graph. One more example is given, which is not a perfect positive correlation, which is the opposite of it. Here you see the variable x and y are plotted, and we get the points on a straight line going downward from left to right. So when you get a curve like this, this is a particular case of perfect negative correlation. That means that the values of the variable move in opposite direction. When x is suppose increasing, y will decrease, or the reverse way, and that's the case of a perfect negative correlation. So scatter diagram helps us to locate the correlation depending on whether it is positive or negative. One more example is given here, which again indicate a perfect negative correlation when we plot the points on the graph. Okay, that is the case with the perfect positive and perfect negative. In case we get the points slightly scattered around a straight line going upward from left to right, it is partial positive correlation. This is a case of partial positive correlation. That means there is no perfect correlation, but it is partial in nature. Okay, so both the variables change in the same direction, but not proportionately. That's the case here, and we get a partial positive correlation. Now when you plot this particular question again on the graph number illustration number 3. Here again you get a line, not a straight line in fact. The points are slightly scattered around a straight line, and here again it is a case of partial positive correlation. Okay, that is it. If as given here in this question, if we get the points scattered on a straight line, scattered around a straight line going downward from left to right, we get a partial negative correlation case. Okay, here in this illustration on page number 65 on top, this is the case. Again you can come to illustration number 4, where two variables are available, and when we plot these points we get all the points near a line, straight line, but not a perfect straight line, and therefore this is again a partial negative correlation. Okay, so these are some of the examples of partial negative correlation. Now here we see again a graph in which the points are scattered. There's no order. We don't see a straight line or the points around a straight line. In this case, we can say there is absence of linear correlation. Some other type of correlation may be there, but linear correlation is not there in this particular case. So when you get the points scattered on the graph, we say that's a case of lack of linear correlation. Okay, so that is the implication. Now let us quickly go through the merits and limitations of scatter diagram. The scatter diagram has got some limitations and some merits. One is this is a simple method. Okay, method is very simple to know the nature of correlation. Second point is less mathematical knowledge is required. So just an ordinary person with not much background, from mathematical background, can also do this. Okay, so not very expert knowledge is required in knowledge on mathematics is required for following this. Number 3, it also gives some idea about strength of a correlation between the variables. Okay, so if there are two variables, and if we from the diagram we can find out the strength, whether there is high degree of correlation or not, that we can find out. If it's a straight line or around a straight line, closely on the straight line, then we can say it's high degree of correlation, whether positive or negative. The scatteredness of the point suggests whether the correlation is linear or not. So if it is coming in a line or not, that we can find out depending on the scatteredness of the points. There's no difficulty in judging the nature of correlation in this particular case. Then limitation. This method gives nature of correlation and some idea about the strength of correlation, but the problem is it does not give exact degree of relationship between two variables. Okay, so we can't get exact degree of the relationship, though we can say something about the direction of the correlation, whether it's positive or negative, but exact degree of the relationship is not available from the scatter diagram in all cases. That's about scatter diagram. Now you are in a position to work out exercise 2.1, where there are about 3 or 4 questions. In fact, 3 questions are available in exercise 2.1. This is your assignment. You just try to complete it and understand the points explained. Okay, all the very best to you.